I think a lot of us find we don't know what we want to do with our degree after undergrad. And for me, it's the same story.
Hi, everyone, and thanks so much for joining us for this episode of the PAM Talks. The PAM Talks is a student-led podcast showcasing the voices of researchers who are members of traditionally underrepresented groups in physics and astronomy. Each episode, we interview a new physics and astronomy mentor, exploring the universe through the lens of diversity. My name is Becky Booth, and I'm one of the producers for the PAM Talks podcast. But I'm not here to host this episode, I'm just here to introduce it. Now, the PAM Talks team is working hard behind the scenes to prepare an amazing lineup of interviews for Season 2. But in the meantime, we're releasing what we're calling Season 1.5. These are re-releases of the interviews from our original PAM Talks video series that never made it into our audio podcast in Season 1. This is an interview between undergraduate student Victoria Gonzalez and PhD candidate Pooja Woosaree, who has been studying antimatter for her PhD research. Pooja contributed to the antimatter result that was announced in 2023, but this interview took place before the announcement of the results. So if you want to know about that, you can either look it up online or stay tuned for our interview with Pooja coming up in Season 2. For now, please enjoy this wonderful conversation between Pooja and Victoria.
Hi, I'm Pooja Woosaree, and I am in my third year of my PhD at the University of Calgary.
Hi, Pooja. I'm Victoria Gonzalez, and I'm an astrophysics undergrad here at UFC. Are you doing research currently for your PhD?
I am. I do a lot of my research, not only at the University of Calgary, but I tend to travel quite a bit. A lot of my work was done in Vancouver, BC, at a facility known as Triumph, which is Canada's particle accelerator. But I also work at CERN, located in Switzerland, which is the world's largest particle accelerator.
So what's a particle accelerator?
So an accelerator is a series of mechanisms and magnets that are designed to accelerate or even decelerate particles for the purposes of research. For example, in my research, we use a particle accelerator to actually slow down particles and use those particles in the formation of antihydrogen.
Did you know you wanted to do that from your undergrad?
I had no idea I would end up doing this kind of research. After undergrad, I didn't know what I wanted to do. I knew I wanted to work, but it was hard to apply for jobs, and there was nothing that really piqued my interest. I ended up talking to my professors, and in the end, they offered me a position as a laboratory technician.
So it seems like networking played a really big part in starting your master's.
Huge, and it continued to play a big part throughout my undergraduate and graduate career. After 2 years, my supervisor suggested it's time to get your master's degree. And so off I went to SNOLAB.
What's SNOLAB?
SNOLAB is another internationally renowned laboratory. It's actually very unique. It's a clean room facility that's located 2 kilometers underground in an active nickel mine.
With radioactive material?
Yes, actually, natural radioactive material. Radiation is all around us. SNOLAB was designed in order to shield from surface radiation, but it's also kept very, very clean in order to do these high precision physics experiments.
So that was to collect data for your master's degree?
Exactly.
And how did you transition to your PhD from there?
So from there, I attended a conference towards the end of my degree, and I ran into a University of Calgary prof who was giving a presentation on his antihydrogen research. Ended up talking to him afterwards, again, networking, and turns out he had a graduate student opportunity.
So what is antihydrogen exactly?
So a hydrogen atom, we know it's composed of a proton and an electron.
Mm-hmm.
The antimatter version of a proton would be an antiproton. Same size in theory, but opposite charge, so it's negative. Surrounding the proton in a hydrogen atom is an electron.
Mm-hmm.
The opposite is a positron. Similar to an electron, but a positive charge. Antihydrogen is, in a sense, the opposite of hydrogen. Antimatter being kind of the opposite of matter. when the two interact, they actually annihilate.
So they just blow up and stop existing?
Yeah, into a bit of energy. Exactly. At the start of the Big Bang, there should have been equal parts of matter and antimatter created.
Wait, so if there's equal parts matter and antimatter, how are we even here?
Exactly. That's what we're studying, is we want to learn a bit more about antimatter. Where did it all go? Why doesn't it exist in our universe?
So is that your work at the particle accelerator? How does that tie into this theory of existence?
So it's not quite as extravagant. This is the big umbrella that we're trying to research, but my research is simply looking at antihydrogen. We take the antiproton and the positron, form them together using very, very complicated techniques. And my research is, okay, we've formed all of this antihydrogen. Now what happens if we let it go? Will it fall the same way hydrogen falls on Earth?
Wait, so falling like an apple from the tree?
Exactly. If it does, then we've proven another similarity with hydrogen.
And what happens if it just doesn't fall at all?
Then we're going to need a lot more scientists to explain what's going on here.
Like me?
Exactly.
Oh, in the future.
In
maybe.
the future.
All this data that you're collecting, how is that going to help us in the future of physics?
We want to discover how things work, why they work. It's all building towards more knowledge. You can look at a lot of the technology around us. We have it thanks to physics. But the things that we've developed in the past, the theories we've proven, the knowledge that we've gained, has all moved towards developing new things. Anything from transistors in your phones to camera lenses, everything has physics in it. And we can continue using this knowledge to develop greater technologies, for example.
The PAM Talks podcast gratefully acknowledges support from the University of Calgary Graduate Student Association Quality Money Grant Program.